Okay. Hi, I'm Johannes. I won't go into biography details. You can find me on all the social media like LinkedIn, Twitter, Mastodon, all the stuff you need. I saw Samuel has Polywork there. You can find him as Pesse if you want to collaborate with him. I'm also on Polywork. That's a nice network to find collaboration. That's actually where I saw the meetup opportunity from
Yeah. I
Anton.
forgot to mention this
Yeah.
meetup is really special because it's the first time when some people were like contacting me to give a talk instead of I'm hunting for speakers, and that's really great. So I encourage everyone to register on polywork.com.
Yes, I love it. It's actually the second time someone responded. So Anton also responds. So it's not always the case that someone posts the opportunity and also responds to the opportunity. So thanks for that. Yeah. Yeah, that's it for the advertisement for Polywork. I'm here for the future of UI testing biography. I will let out, I will dive right into the talk. And what I'm going to talk is, and I saw that Samuel did this too. He did some kind of definition of what he's actually talking about, and that's what I will do also. First of all, this talk will take around 30 to 40 minutes, depending on my state of mind and how fast I am, because I do a lot of live coding in this talk. So prepare for some of the code. So Samuel didn't show that much code. I will show live demos. Something may go wrong there. Also, the service I'm using at the end is running in the cloud, so maybe I have internet problems. So, internet in Germany is not that great. So user interfaces. When I talk about user interfaces, there are all kinds of user interfaces. And I normally ask, does anybody know the formal definition of a user interface? So if you know, you can post it in the chat. See Anton already typing.
Yeah, I'm trying to type to encourage people.
If not so, I see there's not too many people there. And the formal definition is really, really funny. So when we think about user interfaces, then we think about, firstly, this stuff I have on my screen now, like laptops with keyboards and also touch displays in all different forms and shapes. But the formal definition, I hope I get it right as a German, is the means to input something into a machine. So this can be anything. So there are voice assistants out there like Alexa or Google. When I say, okay, Google, or hey, Alexa, then sometimes if someone has speakers on, these devices are actually answering you, and this is an audio interface. But when I talk about user interfaces here, it means visual user interfaces like laptops, touch displays, and even smartwatches, like everything you can visually see, because that's important if we talk about user interface automation in this talk. Yeah, it is a tool for interaction with a machine. That's a really nice definition. Okay, so when we're talking about user interfaces and how we interact with user interfaces, we have a general problem of how do we do element localization. And element localization for us humans is easy as it could be, because our brain here is a pattern matching machine, basically. If you look at anything, and if I go out with my two daughters and look at the clouds, our brains actually do pattern matching all the time. So there are clouds. This is just noise, random noise, like you would see on a static screen or something like this. This is pure noise, but actually what my kids see, and they have a lot more fantasy than me. I usually see dragons and that stuff, like fantasy stuff I'm into. But my daughters see everything, every animal they can imagine. They often see horses because they're into horses, like daughters sometimes be. A lot of daughters are into horses. I don't know why. But there's nothing in there, in the clouds. Actually, there's no horse in there. There's no dragon in there. But our brain is able to pattern match anything, and it tries to find patterns everywhere. And in the normal world, if we don't look at noise, that's actually extremely helpful, because we recognize a lot of things instantly without even thinking about it because of this pattern matching. Ponies and unicorns. Yeah, unicorns. Yeah, that's another story right there. So when we go to this very, very simple and not very useful login page here, there's only one button, then we see the login page header and we see the button underneath it, and we instantly recognize it as a button because buttons have some distinct patterns on how they are styled, how they look. And that's why you're thrown off if a button doesn't look like a button, or a search bar looks like a button and you're kind of confused. Can I click this or can I click this not? But usually elements on a user interface follow a distinct kind of pattern, like this login button. It's actually, even if it's a simple drawing like this, we see, yeah, that must be a button. It's also login there. So this if I click on login and if I put in some username and password before, then this will take me to some kind of dashboard or after login page. So our brain instantly infers, yeah, there's a button, this is the type submit. So when I click on it, there's some kind of form that gets submitted to the backend. And yeah, the text is login. That's basically what we recognize instantly. This is what we call a visual selector, or what I call a visual selector. When we do this with a computer or a computer framework or something like this, then it gets a little bit more complicated, because computers or frameworks we use for visual user interfaces actually don't see our user interface. They just see the structure behind the user interface and they analyze this structure. So we have this is a web page. What we see on the web page is like the HTML, the DOM that is created out of the HTML. And this is a hierarchical structure and is not limited to a web page. If we talk about Android apps, then there's just a few hierarchy we can analyze. Or if we talk about accessibility trees for screen readers, that's also a tree, so also a hierarchical structure. And what you want to do, if you want to select the element, this button there on the bottom right here, you have this element button. You actually have this computer, this framework has to navigate to this thing here and has to know how to find it in this hierarchical structure. It's not like, oh, I look at it and analyze it. So somehow we have to instruct the computer how to find this element. And this can get tricky and is not easily reliable. We will see why it's not reliable, because everyone hates UI testing. But we will come to that. So when we're talking about the DOM, so let's get to the DOM. Then we're talking about diffs and diffs and diffs and spans and buttons and a lot of HTML tags we use there for our markup. And HTML is a subset, or is it a subset? Yeah, a subset of, I always get this wrong, subset or superset, a subset of XML. And XML is has a nice query language, which is called XPath. That's extremely fast, but sometimes it's also tricky to get right because the selectors are strange to write. I wrote XPath with XSLT for about 5 years in my career already. And I always had to look up how XPath works because it's just strange. It's a little bit, it's not as SQL. SQL is much more expressive, so you can read it much easier than some specific XPath. But you can use XPath and it's extremely fast and extremely reliable. And with CSS3, and that's a long time ago, CSS selectors became nearly as powerful as XPath, and you can use both in most modern or in all modern frameworks to select elements on SQL is friend, XPath is enemy. Yeah. You can use XPath and CSS in every framework there to select elements efficiently. So that's very efficient and fast, and you can use that. And that's the basic, the structure that works, the DOM, that's more or less standard. And then there's a new standard that came in, like the shadow DOM. And the shadow DOM is more or less for web components. If you want to encapsulate a specific HTML component, and a lot of modern frameworks do this, you can say, okay, I put this in a shadow DOM, and we will, yeah, you can see it on the right side here. So there's a div and there's a shadow root under there. So that's basically another HTML DOM, and that's encapsulated. So every CSS that's in this shadow root styles only the component, doesn't spill over to the rest of the HTML document. The global HTML and CSS breaks down to this shadow root, but not the other way around. So you can build your whole hierarchical structure out of shadow roots and web components, and you can test this web components in isolation. That's really nice. But because it's not the original XML standard, you can't use XPath there. The frameworks found a way around it. They navigate into the shadow root, and then you can use XPath. So that's possible. But the basic, if you want to really select something down there, you have to go into the shadow root first. So it somehow breaks XPath, but because of the spillover of the global styling, you still can use CSS selectors even if there's a shadow root in there. And there's another funny thing out there. If you're ever worked in an enterprise company, then you know this. You have applications, and somebody needs a form of this application and says, yeah, we need this form, so let's include the whole application into our HTML document. I basically had this, like there was this form on the page, and this was basically another application that got into my application. So really weird. And if you're working enterprise software, that's some things. What's going on with my daughters? It's like C3PO. Yeah, but let's stop. So if you have this, that's really funny. It's only in enterprise software, I feel, because I've never encountered this in the real world. It's just like if you use internal software, enterprise companies, then it's here. And this looks a little bit like a shadow DOM. And what you really do is embed another document, another complete HTML document into your website. You can use XPath there, but only if you navigate into the iframe there, and you can use CSS selectors there, but you only have to move into the iframe before. So basically, the modern frameworks should be able to analyze and select everything in your DOM element. That's the gist. So when we go to a very interesting Selectors Hub practice page, there are a lot of practice pages to practice XPath, but I like the Selectors Hub practice page because it's so weirdly structured, and you can even see the structure is very, very deeply nested here. And what I want to select now as an example is, okay, we want to select this text field here, user email, enter email, and this is a screenshot when I open Web Developer. And when we look here, yeah, this input field is here, and there are a lot of diffs between it. And what you can do is do a right click and get the XPath for it. And what will usually come out is something like this on the right side. Disclaimer, don't do this at home. If anybody changes something like removing this div class element of virtual wrap because it's not needed for styling, then this will break, because it's basically go down, go down, go down, and as long as until you find the input element. So don't do this. What you actually can do, and this is what where the XPath fun comes in, you can say, yeah, scan the whole document from the root, find me all the inputs that have the ID user ID. And you see it's heavily relies on this user ID. It's a little bit like document get element by ID if you use JavaScript. And you see the basic conceptual problem you have here already. So you have your system under test, and you want to select something, and there has to be an ID in there to find it reliably and to not get flaky automation or flaky tests if you're using a test framework. So anytime this ID changes or it gets removed, your test gets flaky because it gets red, because it cannot find anything with the input ID user ID anymore. And in my early career, I did some Selenium. I think it was Selenium 2 already, like 2012, 13. And it was a nightmare. We had these page objects because, yeah, that was a nice pattern at that time. And we used the page object. And every time we ran the automation, something would break because front end had changed some ID or some structure or something like this. So what you basically have to do, and a lot of teams do this with success, they say, okay, we have a template to create user IDs or element IDs, and we follow a specific review and coding process to get the same structure, to get the same IDs in there, and it's predictable. And we also review the code very, very intensively to not break our automation. So they have this coupling of the system under test and your automation or your tests, and they just are successful with a process around it. But what you actually want is to separate this process. And of course, you can do this also with CSS selectors, but we leave that to the demo. So let's try to code something here. And the first thing I put out here is Cypress. Cypress is like Selenium, or I think Playwright is the most modern framework you can use, because you can also automate on an accessibility tree. But I like Cypress because it's fast and yeah, just personal preference. And I have this XPath practice page from Selector Sub locally, so I don't have to download it. And I say to Cypress, yeah, visit this, and I hope it's readable. I think it's already readable in Zoom because it's digital. And what you want to do is, okay, you say, Cypress, please give me all the inputs with the name company. And there you see one first problem. There's no ID for the input with the name company. And actually there are two with the same name. So what I want is the second one. So yeah, so it's array based, is an array what you get back if you select this and you want the first the second one. I hope I got it right with XPath, and the 0 would be the first one, and that's not what I want. I want the second one. So and then I want to type in my company. So you already see you need a little bit of knowledge on how to write XPath, and it's not actually pretty, but we will see it should be fast. So let's switch to my Cypress thing here and run the test, and let's see where it comes up. Yeah, it's here. Yeah, come on. So here's my spec I just wrote, and you see, open it fast, and it's already here. So you see it's blazingly fast. So if you're doing browser testing, that's amazing. The tests run like and are ready. And Cypress has this really nice reload feature. So if we want not the company, but something like, okay, we want to, let's remove this here and say, we want to now type something into the password field. You can do this with CSS. So select the input element with the ID pass and type in my totally secret pass. So let's see how that looks out. It already typed it in because it's fast. Let's run it again. Then we should see that something should come into here. So that's how it works. It's fast. It's cross-browser also, so no need to do anything fancy. Yep. If you're testing browsers. Then we have a text field in this practice page, because it's a practice page. There's some nasty things in there like shadow DOMs, and also this one here. Like if you say I want to get the user ID and type in my username, and get this, then it says, oh no, that doesn't work because failed because this element is read only. But if you click here, you can type something in there. And what actually is in there is some JavaScript who prevents you from changing this if it's not focused. So if it's focused, you can type. If it's not focused, then you can't type into there. That's basically preventing you from automate this stuff. So the first thing you want to do is get the focus into it and then type. Yeah, scroll down, and now it typed it in. So basically what you're reproducing here is user interaction. So you have to reproduce the thing the user has to do to actually enter something into the text field. But this is not what you actually do in these frameworks here. And then I want to show another thing. We have a shadow DOM in here, and let's see where the shadow DOM is. And it's under username. So we get the element username, and then comes the shadow DOM. And this is the workaround they found because it's not working with XPath, because it's not standard, not a standard here. So they say, go into the shadow, find this weird looking ID and type in super user. And this should give us here. So this should be, if we look at inspect, this should give us, let's do it again. So now it's really, where is it? There's it. Yeah, you see it. Here's a username. We navigate to the username, go into the shadow rule, and then we can get something else here. So that's basically, and let's remove this here. We also have relational selectors, but I talked too much already, so let's do this more. But what Cypress can do is do something like get an input that is closest to some other element, and then you can type in really close in this element. That's cool if you want to test responsive layouts. So if it's on the right side, if a label is on the left side and the input on the right side, or if it's below, that's not important because you say give me the nearest or the closest of this label, and you always get the right input field. So that's how Cypress does it. Let's switch back. So this is more or less the current state. And if you look at my not complete table, so if you want something to be included here, maybe your open source framework or your vendor framework, just write me, I will test it and put it there. That's no problem. But basically what we have there is the code tools for the formal DOM, because you saw we automated on the formal DOM, like the IDs, the text, the input fields, the buttons. And there are two kinds of tools there. There's the code tools. I use code because I'm a developer, like Cypress, Cucumber, Selenium. There's also Playwright that didn't fit in here, but it's there. And then you have graphical programming. That's more or less like we specify workflows in a graphical way. But actually, they're also using the formal DOM to automate, but you just don't write the code I wrote here. This space is completely explored. The tools are really, really cool and stable and fast. So if you're doing browser automation, go for this. That's perfectly fine. And you can find a lot of tutorials. The documentation is great, at least for these three. I know, and also for Playwright. So let's do this. And what's actually in the work, so actually implemented, and I see a lot of enterprise tools doing, are smart selectors. But before we talk about smart selectors, let's talk about why do we need something like smart selectors, and even the next stage we saw beforehand, like visual selectors. What we're actually seeing in the last years, and when I started programming in 2012, there was Cordova, I think, or what is it, Cordova? One of these two. And the hype was all about cross-platform application development. Write once and compile everything out of it. Web apps, native apps, desktop apps. Cool idea. It didn't take off then because it had a lot of problems. But with React Native and now Flutter, we at our company see a lot of people actually doing Flutter, which I find kind of surprising because it uses Start, which is not a very common language. But they're doing a lot of Flutter because it seems to be easy, and you can compile native Android apps and native iOS apps out of it, and also web apps. And I used it for developing a sample app for tool, and actually it's really nice. It's fast and nice, works out of the box, so the development workflow is really cool. And I now know why so many people are using Flutter. And you get all the benefits from native apps. So you have a native app, and you can use the native APIs of your phone or your operating system in that space. So that's cool. It's fast. It feels like a real native app, even if it's not a real native app from the code base here. When we talk about native Android, native iOS, or even sometimes in the web, like on Google Maps, you have this canvas elements. So can we go back? Do I have a Chrome here? Actually, where is it? If you go to Google Maps, let's see. Then this is HTML, and there's some HTML, but all of this information here is a canvas element. So when we inspect this, I can't inspect this because it's a canvas element. Let's open it with a shortcut. Can we make this a little bit bigger? Yes. So if we look here and say, give me this. No, now it's gone. So in there should be something like, Can I select this? No, I don't want to select this. Yeah, you already see that the problem with, yeah, there's the canvas element. Now I got it. So everything you see, the whole map you see here is buried in this canvas element. When I studied, I did some drawing in a canvas element. That is really funny, but actually you can't get anything out there with the current tools. So if you use Cypress or Playwright, yeah, you're stuck because you can't say, yeah, click on Belgium or Brussels here. That's actually not working because you can't select it. Your tool can't analyze what's in the canvas. And if you're talking about native apps and embedded devices and iOS, yeah, that's basically the whole problem you're running into. You can't select something here. Yeah, you can't use XPath. You can't use CSS selectors, even with tricks. And canvas elements are technically 2D planes, and 2D planes are like a black hole. If you've ever seen how embedded devices are tested, that's actually really cool because they have this elaborate setup and sometimes hands who hold styluses and use touch displays. And what they usually do is use coordinates / AI and do visual regression testing or visual regression and say, okay, click this coordinate, and they're programming on coordinates. However, when the UI changes, then your coordinates fail and you have to reprogram your test suite or your automation suite. So that's also flaky. So that's a little bit of a pickle you have here. So what vendors now come up with are so-called smart selectors. And I heard a very interesting definition of smart. Smart means like they want to watch your things. So everything that has a smart label in your home just is used for observation of your habits and that stuff. But aside from that, smart selectors are basically a cool marketing term for 3 techniques you attach after a classical selector fails. And the first technique of smart selectors is optical character recognition. This is a really old technique, I would say. But what it does is, okay, if you're clicking a button with a text, you say, okay, I'm clicking the apple here. I want to click the apple here. And if apple is spelled with a euro sign, or it's even called APL or EPI, so the L is wrong here, then it should be recognized as apple. Depending on your distance measure, I always say it's Levenstein distance because it's easy. Levenstein distance, there are a lot of different measurements out there on how you calculate distance. You can say that should work. So if you're classical selector phase, do OCR instead. Next thing, and a lot of people who do visual regression testing might know this, you can also say, okay, I take a screenshot of my login button here and search picture in picture or image in image search on the right side here. So if I have my classical selector phase, yeah, just search this image here. The downside of picture in picture search is that it's extremely performance intensive. So it takes a long time actually to find this login button here because you have to basically search for all the pixels that's in there in the right order. So you can do this. Maybe you take a performance hit. A relatively new thing, and I didn't know this before I read about smart selectors, are relational selectors. I showed this before with the closest in Cypress, and I will show another tool that has a lot of relational selectors, Tyco. What you can actually do is, okay, I don't want to use the exact ID or want to use the exact location. I can do something like, okay, I want to type something in a text field, and I want to type in test, and I say the text field is below email. If the form I'm entering or I'm entering this test in here is accessible, then every input field has a label and not only a placeholder. And this should work. So it's a nice way to add some stability to your selector here. And what a lot of enterprise tools promise there, we are implementing smart selectors and self-healing tests. That's what it all leads to. So if your classical selector fails, you have 3 fallbacks at best. They say we have smart selectors with machine learning, artificial intelligence, and fuzzy matching at best. Everything meshed together and no explanation on how they actually do it. And what you can do with self-healing tests is like, okay, we have this sign-in button and some German developer changed the ID to anmelden. but it should be signed in. So if you have a test script like in Cypress and say, okay, I want to select on the ID that's called signed in, this test would fail. That's not good. But then you can program a fallback, like, for example, picture-in-picture search, and select on sign in, like this picture here. And then the test becomes green again, so that it doesn't fail. I was already wary about the idea of self-healing tests, and I will tell you why. Self-healing tests basically mask failures. And you don't want your tests to mask failures. So if something gets into production, your test might be green. But what if some other script or something like an automation or listener in JavaScript depends on this ID also? So it says, yeah, I want to attach my listener to this ID here. Yeah, you have an error in production. You have a bug in production. So self-healing tests, yeah, use them with caution. Use them with caution. And also, these three techniques don't come without a cost. You have to maintain them also. So basically, you're adding to your maintenance of your test suite or your automation suite here. So self-healing tests, double-edged sword, I would say. But you can do them. Do not overdose, yes. What I wanted to show is like, where's my visual code, is how Timecode does the relation of selectors. So let's remove this here. Timecode is open source. Actually, it has a nice test recorder. You can interactively create your tests, but I won't show this now. And it has, for me, the most nice syntax here, nicest syntax here, where you say, okay, this is more or less like natural language, where you can say, okay, I want to write Timecode test automation into the text box that is below submit. And Timecode also has above or right of or left of, but I only want to show the text box below submit. And we also take the same practice page here. So if I run this test, and I have to switch to Timecode. Before I started, Timecode is limited to a Chromium browser. If you don't know Chromium, Chrome is an open source browser based on the Chrome engine. I think it's V8. Is it V8? I'm really outdated here if it comes to browser.
Yeah.
It's still V8, yeah. And yeah, it spins up or downloads the Chromium first, and then it starts it. So cross-browser testing is not per se possible, but you get all the benefits of relational selectors. And let's run this and hope my Chromium comes up. So it's here. And if you're fast and it doesn't, yeah, you saw how it selected the right thing here. So yeah, it should below submit. I said below submit, and it posted it here. Now it's gone. Where is now? Yeah, okay. I program it that way that it removes itself after 3 seconds. I wanted to show this tool specifically because I'm a coder, and it was more or less the only one who had smart selectors in it when I wanted to code something. So if you know a tool that has smart selectors and is actually open source and I can use it in my demo, I would be very happy there, because all the smart selectors there are for graphical programming tools and they're usually paid for. And you might know some of these, like Ranorex I hear a lot. I haven't used it. I think I have used SmartBeer once a few years back. But yeah, so smart selectors are more or less an enterprise tooling thing. So you have to pay for it to test it, and you can't really figure out how they do it. But you can use it for self-healing tests. So when we want to get to the visual tool space here, that's where the future is, more or less. So let's go there. When we talk about visual testing or visual automation, then what first springs to mind is visual regression testing. And that was already a thing in 2012 when I graduated. And the tools at that time were very, very flaky, because what you had to do is take a snapshot like this one, and in any browser, And then you said, okay, when I do a test run and want to see if my layout still holds the thing I want to hold, so there's no regression here, like on the right side, this login button is green and not red, then they took another screenshot and matched them pixel perfect. And pixel perfect matching is really flaky, or was really flaky back then, because even if you use the same browser on the same system, that sometimes failed and you couldn't tell why. And then I talked to graphic designers who were always like, oh, now it's breaking, or front-end developers also. I realized, okay, the browser engine, even if you use the same browser in the same version, the same system, sometimes renders things differently, depending on its state of mind or whatever. So pixel perfect matching was always a problem here. Yeah. Newer tools are a little bit better, and that also comes to the fuzzy matching thing. You can say, put in a threshold. So if it's not pixel perfect, but they are like 99% perfect, then it's still the same picture. Or you can use something like AI. I don't know how AI plays into this visual regression testing. Then you can use something like this. If you want to test your layout specifically, I would recommend Applitoo's Eyes. I tried that out and it's a really cool tool. It actually uses AI, but they trained their AI on layouts. And what you do is do a test run, then it learns your layout, says, okay, there's a sidebar, there's a navbar, there's a news ticker, there's a table, something like this. It learns the layouts and its relations. So sidebar is always on the left, news is on the top, table is in the middle. And then if a test fails and they detect the relations are not correct because, for example, a news item showed up in the middle of the screen, then you can say, okay, is this really a problem, or are these news items pop-ups that usually should pop up in my application? It's not a failure. They pop up from time to time if some kind of if an editor put it there. So you can even say, okay, these are exceptions with a layout. And this is really powerful because they use the relations to objects and not the pixel perfect matching. And it's already also nice to use if you can figure out the documentation. That's a little bit of a problem here, I would say. But they use AI to actually do something meaningful with it, and you can understand it. So obviously, the future of UI testing should be something with artificial intelligence and also with machine learning. For my part, I'm not too deep into artificial intelligence, but to call something like, okay, we can detect elements in layouts now. Artificial intelligence is a little bit too much. You trained a model in some form of way. It's machine learning, and it learned the elements. And I want to show how that actually works. So let's get back to our code. And let's see this. And what I first want to show is the first thing, if we talk about machine learning or artificial intelligence in UI automation, is we have to talk about a model who can actually do computer vision and recognize things like a human user would. Because the goal of UI automation in this sense, UI testing should be, you should emulate your user, not like Cypress or other tools who do code selectors. They use the structure, and that's sometimes not the same thing. Like I showed, we have to focus first this text field, and we show the use case there. That's not your end user. So your framework is not acting like a end user. You should automate like your end user do to actually find bugs that no other tool can. So the first thing you want to train a model for is computer vision. And let's see if that works now. It's always fun with 3. So the first thing I want to see is what can a trained model whose specific training is for UI elements actually see when it analyzes Google Maps. Yeah, so that takes a little bit. But what we see here now is like it recognized text, didn't recognize streets. It also another text. And yeah, this is a drop-down box because that doesn't really look like a search bar. Then we have icons and that stuff. So actually there's a bunch of text and some icons, what it recognized. And it's a tooltip. Okay. This should be icon trash. Okay. So computer vision is already really cool. And I think I removed the tab now and I have to bring it back. Can I bring it back? Yes. So let's see what we can do with the computer vision now. And the first instruction I want to use here, and this is where the part of comes in. How do we actually want to automate a user interface if we are talking about, okay, we want to do it as a human? Because when we are coming from selector-based tools, we always have the problem, okay, if we're automating like a human, we have to automate trivial stuff. So now we are now in the IDE and we want to test our browser. And sometimes some third-party applications come up, steal your focus, and then the application doesn't work anymore. Or a modal dialog comes up, or a cookie banner gets overlaid over your browser, or any other stuff that actually happens to users. And the first thing I want to do is, okay, do a mouse left click, a real left click, and also we can move the mouse with the tool. And we move the mouse to the text field. That's what we're doing the next thing. Type in has this functionality. So first we get the focus, mouse left click, then we move to the text field that contains the text, enter email, and type in something. And when we automate this like a real human user, we actually have to move the mouse, click in there, and then type something with key presses. And let's see if that works out with live coding. It's always fun. And I don't have to interfere. So what we see is a background application come up who steals the focus. If you notice, the focus is already gone. And with a left click, and I hope Zoom didn't butcher it. You saw that the mouse moved here. So this is real, like a real human user, but we actually specified a visual selector, like find this text field with a placeholder in it. Then it moves the mouse, clicks into the text field, and then enters something in there. So this is real human user automation. The fun thing is that it's not limited to the browser. I show it in the browser because it's easy, but you can actually do this on Android also. Then you would do a tap on your touchscreen. Because we are not relying on the structure, we're just using computer vision to find the element. And let's see if we can do something more interesting. Do we have the mouse left click everything? Yes. Okay, we get the focus. Yeah, we know this. We know this already. Yeah, I already commented it here. Remember the read-only text field from the Cypress demo. So we don't run into a problem when we don't automate on the structure. We just have to do the mouse left click to get the focus again. Then we want to type into the user@askui.com in the text and the email. We saw that before, so it just worked. So when we go back to this here, it doesn't work if we use it with a selector-based tool, but it works if we do it like a real human user. Move here, click here, and then do it. So I won't show it again. It's actually the same demo I noticed. And yeah, then we also can do something like relational selectors. So let's comment this out here. What do we want to do here? We want to click on the item that is below the text that has, can you enter name here through automation? It's actually a funny tag. Can you enter name here? Yeah, that's here. So we click on the icon, and we don't know, icons are another funny thing. There are millions of out there, so selecting icons is a little bit tricky, but selecting text is more easy because it's OCR. And we click here, and then we can type something in there. So if we reload this page, so you can't type something in there. You can do it with when you use the structure selector-based tools. Then you don't have to enable this. You can just type something in there because it's working on the DOM. But a user cannot type something in here, just not working. But we can do this like a real human user would with this. So we click on the icon below text, and then we want to do something. Type in the context. Yeah, let's see if that works. It's always a little bit. And I always have to switch to the browser because then it would just do the whole screen computer vision and it would analyze my IDE. So it found the icon. Let's see if it also found first enter name. Yeah. So this is real human, like a real human user would, like a real human end user would. Yeah, okay. I won't show the rest. You can also scroll. You have to use page down. So this is some questions I get. What do we actually do if something is below the fold? Yeah, if you're using a selector-based tool, it just goes down there. We saw that in Cypress. Just put something in here we didn't have to scroll. If you're automating like a real end user, yeah, you have to scroll with page down, for example, or use the mouse wheel or drag and drop if you're like swiping on an Android tablet. So that's what you do. And I think that was all for my code. So we can do computer vision that we saw. And this is where the future begins. I only found 3 tools who do visual automation, only based on visual automation. The first was Eggplant. I think Eggplant was acquired by Keystone. I think that's how they call it, Keystone. I don't know if Eggplant is still around, but integrated into their suite. But what they do is image-in-image search. So they're selecting elements based on image-in-image search. Tricentis claims it does it too, some kind of artificial intelligence, machine learning thing. But I don't know. It didn't manage to get a license. And then we have Apply Tools. I showed you, I told you before, that does layout modeling. Yeah. So this visual selection tool space is emerging at the moment because it's basically the future that is developed now. And I really have to get over these slides because with ChatGPT taking off, we actually see that this is not an outlook anymore. It's already here. But let's go to the left side first, visual question answering. So if we want to do something like, we don't want to specify code actually, like I showed. We don't want to say, yeah, type into this input field, there's a text in it. What we actually want to have for testing or automation is like, please complete the login and check out of this and this article on this specific e-commerce shop. That's what we want to do. And the machine learning, artificial intelligence should figure out how to do that actually. So we don't want to write code anymore. And one interesting thing where we humans are very, very good is visual question answering. So if we look at the left picture and the right picture, there's one really big difference here. So in the left picture, there's a girl and there's a bike, but they are not related to each other. And we can see this as a human. And then on the right side, there's also a girl and a bike, but the girl is walking the bike. So we can answer this question instantly because for us, this is natural. We can differentiate. For machine learning, this is actually really, really hard because what machine learning does is like, okay, I have a girl, I see it walking, I see the girl walking, and I see a bike. But answering the question reliably with high confidence, is the girl walking the bike? That's really, really hard for machine learning and for artificial intelligence. And this is a visual question answering. This is a data set you can train your model in and see how good it is in answering these kind of questions. That's very important if you want to have stable automation. And then on the other side, we have GPT-3, and now with ChatGPT, it gets even better. I stole this from Level CEO, and he asked GPT-3, generate me some startup ideas. And with a large language model behind it, it's amazing. The first startup idea is great. Help people draw up plans for their dream home and then helps them find contractors to build it. That's actually a legit startup idea you could pursue. And with ChatGPT, it gets to a whole new level where you can say, yeah, I can direct the model into something I want. And if we tried out to put some code into there which had bugs and then asked ChatGPT, can you find the bug in this code? And it's actually able to find the bug. And it's also able to generate basic functionality when you say, hey, I have this API here, can you write a connector in JavaScript for it? And it can do that already. And it can, within the conversation, it gets even better. So actually, what we are trying at my company at the moment, okay, can we do something like a ChatGPT integration into the automation? So not specifying any code, but just say, I want to select this, like I want to select this input field, or do the workflow, and somehow can we figure out a way to integrate ChatGPT into something like this? So this is not the outlook. This is basically what we're trying to build. And I think a lot of people are trying to integrate ChatGPT into anything. So I have to change the slide, and it's really exciting. So we're getting away from code, but just saying what we want, and that works. And that's it for my talk. If you want to connect with me, I'm usually on Twitter, but I prefer Mastodon now because I got permabanned by chance at Twitter somehow. It got resolved, but I'm really anxious that might happen again. So Mastodon might be.
Elon Musk doesn't like you.
Yeah, Twitter. Yeah, I don't know what happens.
Great. Thank you very much for your presentation. So I'm again encouraging people to write the questions or just unmute yourself. And as we discussed with you this topic before, I want just to ask the same question I was asking you. If, for example, your tool, Ask UI, struggles with some tricky icons, how you can like work around it?
Yeah, icons are really tricky because usually you have the same icons multiple times on a web page. So for the search icon, sometimes you have 3 times the search icon. So there are 2 ways you can combat this. You can try to use relational selectors. Like you say, I want the icon below some text. Or if you have a very specific icon, like I can also show this because that's actually that's funny. Can I'm on the wrong. So can we bring up the browser again? So on Google Maps, you have this little Street View icon here. And you can basically not select it. What you can do is take a screenshot of it and do a picture-in-picture search, which is called custom selector, but we can also call it image-in-image search. But again, it's image-in-image search. You take a performance hit for that. It's actually pixel perfect matching there.
Also, I'm wondering, when you actually write the test for Ask UI, does it like communicating with your cloud that will actually run this recognition, or how it's implemented?
Yeah, at the moment it's in the cloud. Yeah, but actually it's a Dockerized thing, so it runs on Kubernetes. A lot of companies in Germany have the requirement, okay, nothing in the cloud because that's a screenshot of our application. What's in the making is that we open source the Docker container, and basically the Docker container, you only need our model to use it. So you would get the model and you can run your own thing in Kubernetes or wherever you want to run it.
So basically you can have your in-house installation of it, right?
Yes.
Okay, great. And for me, like always the question, what are the limitations? You mentioned you can work on OS level, you can automate web pages, you can automate desktop applications or mobile, but what are the like obstacles you cannot overcome with this approach?
Still in question are embedded devices, because when I talk to embedded developers, they say, yeah, basically we have no way to tell what's actually running on embedded devices sometimes. So they just have interfaces. That's interesting. We can do computer vision there, so we can not use coordinates, but really say, here's the element, and you can get the coordinates out of it and then click it. So that could be more reliable. So embedded things are problematic. Also, macOS is somehow funny because it has actually the most restrictive permission system. yeah, that we could run into problems because of the permissions. And iOS is still missing, because what you actually use to automate on Android, it's the Android development bridge, and there's something from Facebook actually, which is called the iOS development bridge. Yeah, iOS is at the moment missing.
What are the roadmap for the tool, if you can share?
Yeah,
What
yeah,
you
of
want
course.
to achieve in the upcoming month?
Yeah, so the first thing we implemented, I think last week, was improved OCR. It's a little bit slower, but now it's extremely accurate, because basically you don't want to do fancy thing with buttons, but a lot of things are just there. I want to click on the text, which is basically text on a button. So that's how you would automate. And the next roadmap is, okay, tables are really interesting. And we get a new release for tables. And also we get a UI controller. That's the thing that controls your operating system. And this is standalone. So you can install the UI controller, select your screen you want to analyze. And this will make it much more stable, because it's a complete new implementation. The current implementation is based on open source tools. Like, I think it's called Robot.js. JavaScript, and that's not too reliable on all operating systems. So the main challenges are getting the operating systems to collaborate, to actually act like a real human user.
Yeah, I just wanted to mention that every time you executed the test with Ask UI, all the moves of mouse or typing these characters, everything is simulated on OS level.
Yeah,
so,
yeah, you couldn't see my hands. Maybe I should put my hands.
Because
but actually,
maybe you just fool us.
yeah. There was a funny story when my team was at Web Summit, where they showed a demo of Android thing, and everybody thought it was scripted, but actually there was no script. It's really, you can move the mouse. Actually, it's not that hard. So you have Robot.js, you can move your mouse around. So it's no magic, but not something normal users would do.
Yeah, I see just a really good opportunity to use such tools for canvas automation, as you showed this Google Maps example. Like, the question is, do you have competitors on that side, like something to automate canvas for web applications?
Yeah, the tools I mentioned, like Applitools Eyes, Eggplant, and Resentis, that's the ones we are aware of. But the space of tooling for automation is so big. I haven't gone through all of it.
Yeah. From my side, just one comment. We also discussed it previously. I like the idea that nowadays tools are moving forward user-facing APIs. And I mentioned that there is a tool also that works on DOM level called testing library. And yes, the idea is you're not trying to just repeat old approaches with the CSS paths or XPaths. You want to write your tests using accessibility layer of the page. So how the page looks like for the human, you want to use the same logic. Like, I'm open the page and you see the screen. So the API for testing library would be screen dot find text and then some text, and you will get this element. So you can also like type it inside input field or find some heading on the page or something like that. So I just really like that industry is moving towards human-centric interfaces instead of, like, I would say, not obsolete, but like for me, it looks like more low level and more fragile approach when you like moving on strictly DOM level.
Yeah. If you're talking about the accessibility tree, I saw a demo with Playwright. You can also get the accessibility tree, I know, from an Android app. So that would also be, you don't need a specific technology for Android then, if you use the accessibility tree.
Really good question from Toyer. He's asking, how is the integration with CI tools?
Yeah, that's a good question. I haven't gotten to it for the docs yet, so I'm in charge of the docs. I'm still working out tutorials. Yeah, basically it works in Azure and GitLab CI. I saw the things because it's a Docker container, but the integration is a little bit, it's not as well documented as the rest actually, and the rest is still not perfectly documented, to be honest. But you can run it in a Docker container. We have one customer runs it in Azure pipeline I'm aware of.
If, for example, I'm as a customer would like to evaluate this tool or use it, do you have like subscription based on number of users, licenses, or just minutes of using? How do you charge customers?
Yeah, it's based on instructions. First 500 instructions are free, basically. Yeah, that's how it works. So you can try it for 500 steps. Yeah, Toya posted it. I think maybe there's steps
one
in
more
the test.
advocate of ASCII.
Yeah, so maybe it's called test steps, but I prefer instructions because instruction is like where you say type into something with a text. That's an instruction. Yeah. Cool. And write it to Intercom, so my talk has some benefits because that's company time. I have to justify.
Would be awesome.
Yeah. So I'm advocating for my tool here. I'm advocating for my tool here. But actually, if you're doing real only browser things, I would go with the open source tool actually. So.
Johannes, I have a question.
Yes.
Can you hear me? Okay, yes, you can. So basically, speaking of using like UI test tools on a project. So as we all know, the project, I mean, like in general, it has different like stages of a life cycle, right? Because you don't want to apply your UI test at the very, very beginning of the life cycle of the project because there are so many changes. And it involves, you know, kind of a little bit overhead on creating the test from the very beginning. So speaking of from that perspective, at what stage would you recommend to use UI test kits? And what would be your choice on like choosing the tool that needs the least maintenance effort going along with the like development?
So for the stage,
is it clear?
I hope I get it first, the stage and what tool. Is that right?
Yes, I mean like stage. At what stage would you recommend to start writing UI tools, tests, sorry? And what would be your like choice in terms of support, like to having the least effort on changing UI things? I mean, what tool would you
Best
choose?
Return on investment. Yeah.
Yeah, kind of. Yeah, right. Just get lost a little. So what tool do you think requires the least maintenance to support the development process? So speaking of that, I mean that, for instance, we have like several developers and they constantly change or test the ideas on the website, for instance, right? So to support these changes, you require a lot of work from QA team. So what tool requires the less effort on like going along with the rapid development cycle?
I would say that depends.
Yeah, yeah, yeah.
It's
It is
really,
open
really hard to
discussion, right?
tell, actually. So for me, I never was in a QA department, so that's at the developer point of view. So every time the UI tests came in, it was more or less like when the layout became as stable as it could be in development. That's when we started in getting our QA team for UI tests involved. That's basically what in every project I did in 10 plus years happened. So we didn't start layout or UI testing before that. And for the tool, it always depends on how tech savvy your testers are.
Mm-hmm.
So we had testers who didn't know how to open an IDE. So it's hard for code. What I actually prefer is, as a developer, is like I need a code tool. That's why I showed code tools, because I think they are the most flexible. So it's very easy to get your test cases into a database and get them out there, because that's also code. There are libraries like Samuel showed. You can do anything as a developer, and it's always hard if you have testers who are not able to write the code.
Yeah, sure. So, and speaking of how this process is organized, for instance, there is like a few developers working on the UI, and then there is like feature A and B, for instance, they develop at the same time. And at what stage, like QA team starts developing their UI tests? I mean, for instance, there are like developers and they work on the changing the color of the button, right? So at some point of time, they finish their work on the feature branch, for instance, and at that point of time, they basically ask QA team to start working on a test, or it might be like they might work in parallel. Or once the UI changes are accepted and pushed to the main branch and delivered to the production UIT, whatever environment we have, and only after QA starts to implement like tests on the functionality that is already delivered. So what is the process you would recommend on that?
I fear I'm out of my wits here, and I don't want to give any recommendation depending on.
Speaking of experience.
Yeah, experience. It was like every time we thought, yeah, now the UI looks stable. Like we won't change the layout, for example, anymore. That's always when we involved Q&A in my former companies. But I don't know how you would set up the whole process there, because it was more like, yeah, we are now done with the layout, more or less, and then QA comes in and does their thing, basically. We had our own UI tests, but yeah.
It is a very common problem, because basically if you work in a team and you have like the task, for instance, to create another form for user input, and then you as a developer, you complete your work, and then there is a time where QA team comes in and say, okay, we need to test it out. And then some other changes apply to that form. So it is like constant change and constant like following up to the developers by QA team. So they don't work in sync usually. So yeah, it is very common problem. So I wanted to know your idea on how that might be or could be or should be implemented.
Yeah, what I really like to solve this problem is to include the testers in the team. So basically, testers know beforehand if a change comes. So this seems like what you describe is like this typical waterfall process.
Yeah.
Like you have separate teams developing and then testing and then getting into production. And that's not what I like. What I actually like is talking to customers, implementing it, and the testers are already there and know what's coming and can suggest, hey, this would break something.
Yeah, or the other way around, where, for instance, your developer is responsible to write the test as a part of the new UI, whatever form or functionality itself. So in that case, you don't need like a QA team. It is like somewhat becomes similar to integration tests for developers for backend. in this case, yeah, it might be the responsibility of the developer.
Every discussion ends with statements, we don't need QAs.
No,
We don't
no,
need
no. I
No,
love
no.
QAs. I love I met so many cool QAs. That's so for me it was always like, how should this be? And then you talk to QA and then you had an idea of how it really should be. Like every QA understands the requirements better than anyone else.
Yeah, true. All right, yeah, thanks.
Okay, looks like we had all questions. Again, thank you very much, Johannes, for coming for the meetup, for the great talk, for answering the questions. Thank you guys and have a great evening.